Hello. Let me should see the desktop and let me start some programs up. Can you hear my voice? Do you see the desktop? Does everything seem okay?
Yes.
Okay, great. Thanks. Okay, still want to get the chat window up. Try to. Okay. Okay. All right. I think I got everything set up. So let's see. First, I've got an announcement here about seeing a programming assignment, but I didn't get it finished writing yet. So if you go here, it's not available yet. I hope it'll be available later today. Okay, so there's going to be one last programming assignment about what we're talking about today and next week, about writing an example of a class. Okay, but so it should be up there later this afternoon or so. Okay, and there's another reading assignment further into this chapter on writing classes. Okay, so today we're going to talk about the ideas from uh, this reading assignment here. Okay, so we're going to talk about what's in there, and then this is the reading assignment for what we're going to talk about next week. Well, actually, we're kind of talking about all these things at once. So even today, we're going to be talking about some of the ideas in here. It's not complicated, but there's a lot of little ideas. So so we're going to pretty much kind of talk about them all at once, though they're written about in separate sections. Okay, but you'll see it's a matter of digesting the whole idea. There's lots of little bits, but it takes a while to digest all of it. So we'll talk about most of it today, and then we'll go over it more examples and more examples next week. Okay, and your homework assignment is very much about the things in this chapter 6 here, this section 6, 6.1, 6.2, 6.4, 6.5. Okay, so the last thing we did, let's see, last thing we did the other day was we started this rectangle example. Remember, well, we did this example on Monday, and we used Java's point and Java's rectangle. A point was something that held an X and a Y coordinate, represented a point in the plane. And rectangle, remember, we had a picture of a rectangle. The picture of a rectangle is that it holds an X and a Y coordinate, which tells you where its upper left-hand corner is. Then it holds a width and a height. So it holds 4 numbers, X, Y, width, and height. And that describes a rectangle. Okay. And Java has those built in. Okay. But we started to write our own rectangle. Okay. And so we want to start talking about this idea. What we're gonna do today is write our own point. So we're gonna start writing our own point. We're gonna talk about what goes in defining our idea of what a point is. Okay. So what I'm gonna do is open up another window, the Java Visualizer, and start defining what a point is. Okay. Okay. So I'm going to define a class point that describes point objects. Okay, I want to describe for myself, rather than using Java's built-in point, I want to describe describing what a point is. Okay, so a class is something between braces, and inside the class we're going to define the data. Remember, a class is going to tell us how to build an object, and objects have data and they have methods. Okay, so we're going to define what data is in a point, and then we're going to define what methods you can call on points. The methods will manipulate the data. Now, we kind of been talking about this all semester, but we never wrote our own classes. We always used things like string class or scanner class or so a couple of the other classes we've used. We've never sat down and wrote what is in a class, an object. What, let's design our own object. Let's say what data is in it. Let's say what methods are in it. Okay, so here's what we're going to, the data in a point is going to be an integer x and an integer y. Okay, the location of the point. Okay, so that's the location of the point. So to us, this thing, a point object will represent, you can't say that a point is a point in the plane, because a point in the plane is something you draw on a piece of paper and pencil. But a point object will represent a point in the plane. And that's one of the key ideas in Java programming. We design classes that represent things. They aren't the thing. Like, for example, a real famous example is to design a person class. Okay, a person class would be used by a company or a school to represent a student or employee. A person class would have the data in a person class. If I was to just sketch that out, so I could have a class person, and it would have data, and it would have methods, these wrong slashes. Okay, and for example, the data on a person would be their name, and a convenient type for that would be string. Okay, so a string that's their name. Okay, and what else might you put in a person? You might put their birth date. Okay, their birth date. But there, the thing about birth date is it's not obvious what the type for that would be. Like, uh, we don't have an obvious way of saying what a birth date is. There is in Java something called a date. And you could go read about what a date is in Java. But on the other hand, you could just think, oh, like, how would I represent somebody's birth date? Well, you could just say something like int month, int day, int year, and make those three combined their birthday. Yeah. So you could say B day, the month, B day, the year, and B day, the day. Okay. Yeah. So there's a birthday. Okay. And then you might think of what, if it's a company, you could have an int that's their salary, something like that. Or maybe you have an int that's an ID number. Okay. So you describe what you think is the data. And as a person writing this, you get completely decide what the data should be. What do you need in a person? For example, a company would need something like a salary, but if it was a student at a university, you might want a double for grade point average. Okay, and then you'd have to decide what kind of methods would you put into a person. Okay, so you just say you have a person, you write class person, then you describe what the data would be in that person. Then we can see what methods. And in between the data and the methods, we're going to be something called constructors. So that you can go up here and say something like person Jane equals new person. And you could build a person object, but you have to decide what goes in there. What would you put in there to describe this person? That's this idea of the constructors. Okay, so a class is data, constructors that let you build objects of that kind of person, of that kind of thing, and then methods. Okay, now back over here. After the data, we'll have constructors. okay? And then methods. Now here, the data for points just this, X and Y, okay? Now up here, if I want to build a point, P1 equals new, it's kind of obvious what kind of constructor I need here. I need a constructor that takes in a number and another number. That would be what I would want. I'd want to be able to say, I want a point at 2, 4, and I want another point, P2, a new point at, say, -3, 0. Okay, so here's how you define a constructor. Notice that this looks a little bit like a method call. It looks like I'm calling a method called point. So down here I say public point, okay? And then I say what types it takes in. See, this constructor took in 2 integers, so I'll say int x, int y, okay? And I'm declaring a constructor. It looks a lot like I'm declaring a method. Then here I'm going to put the body of the method. What does the constructor do? Okay, well, I've got an x here and an x here. And what I really want to do is I want to say that this, I want to build a point. That point's going to hold these 2 numbers. Now, in this case, I want 2 to be put into there. So when I call this constructor, that 2 goes into there, because that's the argument, that's the parameter. See, here are the arguments. Just like when we talk about methods, the arguments are 2 and 4. Here, the parameters are x and y. That 2 argument gets copied into that x parameter. The 4 argument gets copied into the y parameter. But we want them up here. These are called fields or instance variables or attributes. Everybody's got their favorite name for this. Okay, so these are called fields, or you could call them instance variables, or you can call them attributes. Okay, that's the actual data that the thing is that's being held in the object. See, I want the object to hold that data. Okay, so I pass that data to the constructor. The constructor's job is to put that data from there into there, which then stores the data in a new object. So it's the constructor tells us how to build an object. We're going to build a point, and the constructor says what to put inside the point when it's been built. Okay. Now, normally when you assign a value to a value, you'd write x equals x. Okay, but this doesn't work. This x I'm supposed to take this value and put it in there. I'm supposed to take this value and put it in there. But I can't write this. This doesn't make any sense. So Java's got a funny notation. I'm building an object. I think of the thing I'm building as this object. I'm building this object. So this x here is this x here. It's the x from this object. This is very confusing. Unfortunately, this is the part that's going to take the most effort to get used to. What does the word this mean? I'm building an object. You know, if we go back over here, let's see the examples we did here. See how we did? We said new point 1, 2. Now here we're using Java's built-in point. We're really saying build us an object, which would be on the right-hand side of the Java visualizer, and put in that object a 1, but it gives it the name x in the object, and put a 2 in the object and give it the name y. So we're asking there to be built in memory an object holding 1, 2. Okay. Over here, I'm saying how to build that object. And that object I'm building is called this object. I'm building this object. And this object's y, it should get the value from that y. So the letter y by itself means that y. If I want to talk about that y, I say this dot y. For I'm in this object, the I in this object, the y in this object should get that y. And the x in this object should get that x. Okay? All right. So now I've passed the parameters from the constructor into the fields of the object. Okay. I've got the arguments of the constructor call, the parameters of the constructor, and the fields of the object. And we have to use these words. Yeah, I'm going to keep asking you to use, when we talk, we have to use these words, because otherwise there's just too many things around. There's this 2 here, there's this x here, there's this x here. Okay, yeah. And, or for example, even I could even make it a little bit more confusing here. I can say int x equal 2, int y equal 4, and then I could say x comma y. Now the arguments are x. Well, the argument's really 2 because the value of x is 2. Okay, and the other one is 4. Well, the argument's y, but it's really 4 because y is 4. Okay, so the arguments are still 2, the value of x. Okay, and 4, which is the value of y. Okay, so the arguments are 2 and 4, but 2 is the value of x. But notice I've got an x up here, I've got an x over here, I've got an x over here. Okay, I got to be real careful. That x is the argument. That x is the parameter of the constructor. This x is in the field in the point that I'm building. Okay, down here, the argument is, for example, -3. The arguments are -3 and 0. So in this constructor call, this guy is a -3, and we want that -3 to end up in this guy's x. And this argument here is 0, so this parameter is 0, and we want that 0 to end up in this guy's y. Okay, notice that in this function call, there'll be a different this down here because we're building a different object. One of the reasons why this is confusing is this was a really bad word to use here. This is such a common pronoun that when you're trying to talk about this, you start saying sentences like this is this. Yeah, the this in this object is this. Yeah, there's just here we're using this as a variable name, but it's a common pronoun in English, and it ends up being, those a really bad choice on their part to call it this. There's a couple other languages that use the word self there, which is probably a way better word for this. That's you're saying the x in this self. Okay, self is the object itself. It's, so you think of the object, it's, instead of thinking this object, you think of itself. So you put that x in the x of itself. At least it has the advantage that the word self is much less common to use than the word this. Okay, so you don't end up with sentences with the word this in it 5 times, where sometimes the word this is this keyword. See how it's got a different color to it because it's part of the Java language. Okay, so sometimes you talk about this and you're talking about this as the keyword this, versus saying, oh, I want this point to be 2, 4. I want this point to be -3, 0. Well, there I'm using the word this in its normal English sense. This point, this point. Here I'm using the word this in its Java meaning. It means the instance, the field variable up here. Okay. Yeah, they could have called this field. the field X. Okay, yeah, that would have been better than this, because that's what we want the field X to get. We want this parameter X to be put into the field X. We want this parameter Y to be put into the field Y. That would have been a way better choice of a word for the keyword here, but they chose this. Okay. C++ uses the word this. JavaScript uses the word this, pretty much to mean the same thing. So Java, C++, and JavaScript all use the word this to mean this idea of that you want to move from the parameter to the field. Okay, all right. Now, we actually should be able to compile this. We've got enough code now to say how to build a point object. Okay, so I can now go forward. Now I create a local variable X and a local variable Y in main. Then I'm going to use those as arguments to this constructor call. Now, that's going to act a lot like a method call. It means I'm going to jump from line 6 to line 21. So I'm going to jump from point XY to this constructor. Constructors act a lot like methods. So I jump down to the, whoops. Oh, shoot. This is a bug in the Java visualizer. I forgot about this. This is a bug in the Java visualizer. The Java visualizer has its own point class built into it. Deep inside the Java visualizer, there's a point class for some reason. And it conflicts when you try to design your own point. So I need to change the name from point to, let's see, I'll just call it just stupidly this. I'll misspell point, P-O-I-N-T-T. Okay, this is really dumb. This is just something I have to do because of the Java visualizer. The Java visualizer actually has a point. It took me a long time to figure out what this error was when I first ran into it, because they noticed the error message was really weird, and finally realized that it meant that they had their own point class somewhere inside. Now watch. All I did was change the name. No, let's see. Oh, I forgot to change it here. Point. Okay. So I'm going to spell it P-O-I-N-T-T. Okay. Okay. So now I have my two local variables. Okay. Now I'm going to jump down to this. I'm going to jump from line 6 to line 21. Okay. Well, I jumped actually to line 20. Now, what it did is at line 20, it started building this object. Okay, see the word this. This thing is pointing at the object we're about to build. We're building an instance of point. And X and Y get default values of 0. Okay, notice I haven't even got to my code yet. But at this point, I jump to line, they show it as being at line 20, the opening brace. And what that does is it starts the process of building this object. Okay, so now this word here is an arrow. It's a reference variable. This thing is a reference variable to the object that we're building. This is a frame. These are local variables. See, X and Y here are these local variables. They belong to the constructor. Okay, so this X belongs to the constructor. This X belongs to the object. This Y belongs to the constructor. This Y belongs to the object. Okay. See, this Y here is that one. Okay, this Y here is that one. Okay. Now I'm going to change. Now I'm going to copy that X over to there. So that's going to be line 21. Okay, now line 21. See, copied that X over to there. I took the argument X, or the parameter X, and put it in the field X. Okay, now I'm going to take the parameter Y and copy it into the field Y. So I'm going to copy this Y over to there. Okay, and I'm done with the constructor. Okay, I've built this object. So now the constructor is going to return up here to line 6. See, we're going to go back to line 6. Okay. And then we're going to create the variable P1 and point it at this guy we just built. Now, unfortunately, the guy we just built momentarily disappears. He's still there. This is another little failing of the Java visualizer. The object we built is still there. Okay, that's the right-hand side. We built this object. Remember, we said this line does 3 things. It builds an object, it creates a reference variable, and points the reference variable at the object. Okay, we've finished building the object. It's really sitting over here, but there's no arrow pointing at it yet. So the Java visualizer doesn't show it because it doesn't have an arrow pointing at it yet. When I click forward, it's going to create the reference variable, put the arrow in it, and so then the object we built reappears. They seem to only be able to draw an object when there's an arrow to it. Okay, and that's a little bit of a mistake on their part, because right after you construct the object, when we go back to, like right here, we've returned from the constructor. See, the object's there. We've built it. We go forward. We return to line 6. We're done doing the right-hand side, but we haven't yet done the left-hand side. So the object's sitting there. There's just no arrow to it yet. But since there's no arrow, they seem to be unable to draw it. So when the arrow's there, then they can draw the object again. Okay. Now I'm going to do this whole thing again. I'm going to create another point object. Okay. I'm going to call this constructor with parameters -3 and 0. Okay. Now at line 20, I'm building this object. So this is the one I'm building now. Yeah, this is the one I built before. Now notice the word "this" points to here. Before, this pointed to this one. When we were building this one, this pointed to this one. Notice how the word "this" is appearing all in my sentences multiple times. This variable is pointing to this object, the one we're about to build. The last time we called a constructor, this variable was pointing to that object, which was the one we built the last time we called the constructor. Okay. At first, Java puts the default value in the fields. Like the default for an int is 0. The default for an int is 0. The default for a Boolean is false. The default for a double is 0.0. So initially, when Java builds the object, when it first builds the object, it puts default values in the fields. Then it lets you update those fields. So now we're going to update the X field to that argument, that parameter. So we're going to be copying now this X. We're going to copy this into there. Okay, and now we're going to copy this into there. Notice that this happens to be equal to that, so you don't see it happen. Okay, so I copied that into there. Now we're done building this object. We're going to return to line 7, and we have to finish line 7. To finish line 7, we have to do the left-hand side of line 7. Okay, so we're going to return. Okay, now the object we just built disappears. It shouldn't, but that's just the way the visualizer works. The object we built disappeared because the arrow hasn't been built yet. Click forward, the reference variable appears, and then they can put an arrow in it pointing to the object we just built. Okay. Okay, so we can define our own constructors. Now, let me show you next. That's not the only constructor I can make. Here's another constructor I can make. Here's an idea of a default point. If I just create a point and don't say what to put in it, okay, then I can decide for myself what is a default point. So let's make it this X equal 0, just like, kind of what you expect. This Y equals 0. This is called the default constructor. There's no arguments. No parameters, no arguments. Okay. When you have a default constructor, you get to decide what should go into the fields that you think is just the right default. It may not be. Now here I'm using Java's default, but if I wanted to, I could use some other default. I could make it the point 1, 1 if I really wanted to. I could say that my default point is 1, 1. Okay. So I'll go ahead and keep it that my default point is just like what Java defaults to, okay? Now, here's another thing I could do. I'm going to do kind of a funny constructor. When you define constructors, you get to decide what kind of constructors you want. So here, I'm going to do this. My idea is that I'm going to let you tell me what X to put in the point, and I'll pick a default value for Y. So you pick X. So this is a constructor where you pick X, but you get a default value for Y. So this dot X will be your choice of X. This dot Y will be my default value for Y. Okay, now, is that a useful constructor? Probably not, okay? As someone who's designing a class, you get to pick what you think is useful. This is probably kind of dumb, but I can go ahead and do it if I want. Like if you looked at if you looked at the point class that Java designed, remember Java has their own point class. In Java's point class, they have a default constructor, which gives you a point at 0, 0, and they have a constructor that takes X and Y. They don't have a constructor like this because it's just kind of dumb. But I could do it if I want. And then if I wanted to, I could do one that only took a Y value. Okay. Now here's maybe a more interesting constructor. Can you guess what I mean by this? What do you think it would mean to say construct a point, but here's a point? What might I let this X should be what? What is it? What would it mean, do you think, to construct a point and I give you a point to use?
Would you just take the parameters from that point?
So you're making what? You're just doing what?
It's creating like another variable name for it.
No, no, think of it differently. You're doing what? I'm giving you a point and saying, build me a new point. What word would you think I'm doing here? I'm making
Like a duplicate.
a duplicate, a copy. Yeah, I'm just making a duplicate of the. It's not another I'm making another point, but I'm making another point that is a duplicate. So what I'll do is p dot x. See, I'll take p's x and put it in this x, and I'll take p's y and put it in this y. I'm making a duplicate or a copy. So this has actually got a name. These are called copy constructor. When you're constructing something from the same kind of thing, you call that a copy constructor. I'm making a point from a point. And that might be useful. It's not always useful to have a copy constructor, but in this case, it lets me quickly make a copy of something. Okay. Now points are simple, so I probably don't really need this, but when you have more elaborate objects, it's actually pretty common to have a constructor that can build a duplicate of some object. Okay, so duplicate, copy. Okay, all right. So notice that I've now got a whole bunch of overloaded constructors. Okay, now here's one thing I cannot do. Now, notice that I'm trying to build a constructor that's got the same parameters as this one. I can't have another constructor that says point x, y. It conflicts with this. I can't have two constructors that have the same first line like this. Notice that every one of these other ones, they have something different. Oh, actually, here's a better example. Java won't let me do this one. Here's what I thought this would be. Java's not going to let me do this because line 43 and line 31 essentially look the same. A constructor that takes in one int, a constructor that takes in one int. So this conflicts with line, what is it? 31. Okay. It conflicts with line 31. Now, Java, you might think Java was smart enough to look at the name of that variable and say, well, it's a different variable name, but it doesn't work that way. Because if you think about up here, here's what would go wrong.
So is it kind of like how, like, if it's just the first number, it's always going to be for X?
Well, they just won't let you do that. Like here, is that the first number or the second number? Well, it's only one number, so you could say it's the first number. So you could say it's for X, but Java, what Java does is says, you gave me one number. I have no way of knowing if you meant it to be X or if you meant it to be Y. And Java will just say, I can't do this. You can't do something this ambiguous. Because when it up here, the problem is right here. See, the problem isn't really down here because, well, that's called X and that's called Y. So Java could figure that out. But up here, it really does. See, I just use the number 2. It has no idea if that 2 should go into there or if that 2 should go into there. Now, if it always put it into there, then this thing would be useless because you would never be able to call it. So what Java does is it just complains. It will give you an error message saying, see, do you see the error message? It says, constructor is already defined. Okay. So it said that this one, it didn't tell us where, but it's actually defined on line 31. Okay, now it's line, now I changed something, so now it's line 32. Okay, so you cannot, these are called overloaded names. This, and this are overloaded. I keep using the name point, but this takes no parameters. This takes 2, this takes 1, this takes 1 point, but that's a difference. See, this takes 1 int, this takes 1 point, this takes 1 int. That looks too much like this. Okay, so that kind of screwed me up. I can't do a constructor that gives me that lets me choose Y but gives me a default X. Like this, you got to pick X and you got the default Y, but I can't use this name here. So this one just doesn't work. So I'll comment it out. It just doesn't work. I have a name conflict. I can't have overloaded names that have the same kinds of arguments. If I overload a name, the parameters have to be different somehow. And it's not enough to give a different name to the parameter. You got to give different types to the parameters. Okay, so like here, 1 parameter int, 1 parameter point. That's okay. All right. So you can define as many constructors as you want. Okay, and you just define constructors you think are convenient. Like in this case, this is probably the only constructor that really has to be there. All the other constructors are kind of not really that important in this example. Okay, but so this constructor would be the key one. This one lets you put 2 numbers in there, and the other ones are just maybe convenient, like be able to get a default one, be able to make a copy of one. Okay, now we've got our data, we've got our constructors. Okay, now let's look at what kind of methods. Now we get to say things like, if I want to do something like, what can I do with a point? Like, what can I do with P1? Okay. So for example, I might want to move it. Okay. I might want to move it horizontally by the amount 3. Okay. So this is going to be move the point Okay, so I want to be able to, I want this point to move it. I'm telling the point, move yourself over. Okay, so I need to define that method. So I'm going to go down here. I'm going to say, I want a public method called move horizontally that takes in an int. Now, this is the amount to move by in the x direction horizontally. So I need to give a name to that down here. I think a good name is delta x. Delta is used almost always in programming to mean a change in something. So whenever you want to say this thing represents how much something else is going to change by, then it's real common to call the variable delta something. Okay, so I'm going to tell this point to move its x coordinate over by that much. Okay, now this method doesn't return anything. In a minute, we'll write a method that, see, notice that I'm just telling this point move. I don't get back an answer. There's no need for me to get back an answer when I tell a point to move. So this method is a void method. In a minute, we'll write something that's not a void one. Okay. Now I have to decide what this method does. Okay. Well, I wanted to update the x variable. So this dot x should be changed. So I want this dot x to be this dot x plus delta x. Okay. So I want to add delta x on to this dot x. I could shorten that line a little bit. That's an equivalent way of writing it. That's the kind of the fancy way to write it. This dot x plus equal delta x. It really is just a shorthand way of saying that this dot x gets what's currently in this dot x, but with delta x added on to it. Okay. All right. So there's my method that'll move a point. Okay. Now let's watch a little bit of this happen. We've seen ourselves construct a couple points. Okay, so now I've got 3 points constructed. Okay, now I'm going to tell P1 to move over. So P1 is this guy. So I want to move this point by 3 units. So I go down here, I go into this, and you're going to see now. Now notice that in here, this points to what was P1. See, now if I go back, I'm calling the method on P1. So this is the method, this is the object I want to call the method on. So when I'm inside the method, it's this variable points to this object. Okay, so when inside this method, I'm moving this object. So this keyword pointed to P1. Okay, you can see how this is pointing to P1, and I'm actually moving this X. Okay, so then I click forward, and X got moved to 5, and I'm done. Okay. Okay. Now let me move P2. If I do P2 dot move H by 3, so now I'm going to tell this other point to move over by 3. Now when I call this method on that point, this will be different. In this method call, this will point to a different object than in this method call. And if you pay attention, the word this just keeps appearing over and over again in the sentences. And sometimes this is a pronoun, and sometimes this is this keyword down here. Okay, so watch this take place. Let me get up to where I want to be. Okay, there's my 3 objects constructed. First, I'm going to move P1, then I'm going to move P2. Okay, so move P1. So I go down here to the move method, move H, and this is pointing at P1. See, it's pointing at the same place that P1 pointed at. So this is pointing to that object. So now move that object. Now I'm going to return to line 9. Okay, well, line 9 was done, so I actually returned to line 10. Now I'm gonna jump back into move, but now I'm moving this object here. So I'm going to jump back into move and see now this is pointing down here to what P2 pointed at. Okay. The this in this call now is a different object. See, every time you call this method, you get a different reference in this. Every time you call it, you're pointing at a different object. Okay. So now I'm pointing at this object, and now I move that X. So now it moved over 3 units, and now it's at 0. Okay. Now I'm done and return. Okay. Okay, so we have a move horizontal method, okay? And then we can kind of, if we can move horizontally, why not public void move vertically by int. Now, what would be the variable name now? If I'm going to move vertically, I'm changing the y, so the variable name would be what?
Delta Y.
Delta y. And the use of delta just comes out of calculus. Everybody has decided that the word delta means change in. So you'll see this over and over again, that I'm changing the y value by that much. So delta y, if I call it, now I could say something like, I could give it a funny name like change, but then people will know change in what, okay? Or just, I could just say y. Okay. Yeah, I could even say y, and then I'm going to be doing this dot. If I do, but then that makes it look like I'm giving it a new y. So this is this dot y equals this dot y plus y. That works, but people would they would be kind of confused when you do y. They think, well, you're going to maybe you're replacing y. See, that's not a good name because it's kind of confusing what the role of y is. The nice thing about delta y is it tells everyone right away, oh, you're changing y by an amount. Okay, so using delta in a variable name is ubiquitous, and it's a good strategy to mean that that's going to be used to change something. But the code would work fine if I left it like this. I'm moving by the amount y. I'm moving y by the amount y. I'm moving this y by the amount y. But it makes for kind of not so nice to read code. So I wouldn't really want to leave it like this. I'd rather write it as delta y. So I'm changing this y by delta y. And if you write it like that, it's a little bit harder to read. Notice that this is, people use a mixture of upper and lower case to just kind of make things a little bit easier to read. Some people would write it that way. Some people would write it delta y. Some people like to write it this way. We have names for all these. When you write it this way, it's called camel case because it's like a hump on a camel. You have all these lowercase letters, and then you get uppercase and then lowercase again. So people call this one camel case. See, words start out lowercase and they go uppercase and they go lowercase. So, or like this one, starts out uppercase, goes, so that's called camel case. Okay, because it's like the humps on a camel. Okay, and then other people like to use this style where instead of doing camel case, you separate things by a hyphen. C programmers and C++ programmers use that all the time. A C++ programmer would probably call this delta underscore y. Forget what they call this style. I don't know if it would, maybe the camel case one will say. Because there's a few different styles. Pascal case. Let's see. Yeah, they're not giving any of the alternatives to camel case.
Someone said the word snake in the chat.
Oh, yeah, great. Yeah, that's maybe it. snake case. See, snake case. Good, thanks. Yeah. So C and C+ programmers tend to prefer snake case, and Java programmers prefer camel case. Okay. And you kind of go with the flow. Like if you're a Java programmer, you kind of do when you're writing Java code, you kind of do what Java programmers expect. Then if you switch to writing code in, say, C, you kind of switch to what C programmers expect. So you kind of go with whatever is the preferred style. C++ programmers are in between. C programmers just tend to use this, Java programmers tend to use this, and C++ programmers are all mixed up. They kind of go back and forth between these two different styles. Okay. All right. So I'm going to stick with the traditional Java style of camel case. Okay. All right. Now I've got a move horizontal and move vertical. Okay. So I can move my point around. Okay. Here's another example of what I might want to do. I want to move to. So I'm saying move my point to X and Y. Now this is not a delta. I'm saying move to X and Y. So then I would say this is very much like it's going to look like the constructor. I'm just changing what's in X. I'm saying this X goes to X and this Y is Y. Okay. Okay. That just lets me move the point to an arbitrary place. You could have just asked, why didn't you construct the point at that place? But in a more general program, I might need to construct points and then move them around. So there's a lot of reasons why you would need to move points around. So I constructed the point at one place. Maybe I moved it horizontally and vertically, and then I want to move it to that coordinate x, y. Okay. But then another one I could do is, see, I can just write a bunch of these. I could say move to this point here. Now, what is that really doing? If I move my point to that other point, what am I doing? Does this make sense? Move to P.
You're basically making a new point and getting rid of the other one.
No. I'm not. This is not making a new point. This is moving a current point. Only constructors make new points. So this is not making a point. This point's going to still be there. I'm not deleting it. So what am I doing?
Just changing the location.
Of this one to be what?
Whatever X and Y you have.
Well, what you want to do is you want to describe these things in words like you were talking to somebody. Move to, I have a point. Like here, I'll say P3 dot move to P1. Okay, what have I done there? What would be a nice, you have to be able to describe this stuff to other people. And you're supposed to think like, you're modeling the real world. So think of like pins in a map. What am I doing? P3 dot move to P1.
I'm gonna just take a shot in the dark here. I'm gonna go with you're moving P3 to P1.
Yeah. So what am I doing? If you were thinking of these as physical things, they're going to be what?
On top of each other.
Yeah, exactly. You're moving P3 on top of P1. You're moving them to be in the same place together. So they share that. So you now got 2 points sharing that location. Okay, that might be useful. The reason it's going to be useful is because point 1 might be the center of a square and point 3 might be the center of a circle. And what you're saying is essentially move the circle to be centered at the square. See, so you might use P1 to represent the center of a circle. P2 is representing the center of a square. Then when you say move P1 to P, when you say P3 dot move to P1, you're moving the square to be on top of the circle. See, that's how we start thinking about this. We're going to use these points to represent things. So they could be representing the center of a circle, the center of a square, the center of a triangle, or a corner of a square, or a corner of a triangle. Okay. So now, how would I finish writing this? What would be the first line to write? I'm going to move this one to be on top of P. So what would be the first line?
It'd be like this X equals P dot X.
Yeah. I want to copy. Pardon me?
I just said go crazy. I was hyping myself up.
Yeah, copy the X value from him into this and copy the, what will be the next line then?
This dot Y equals P dot Y.
Copy the Y value from him into this. Okay, so now I've got the 2 points sitting on top of each other and spell things right. Okay, all right. Now notice all these things have been void. Okay, here's something that's not going to be void. I'd like to know if one point is equal to another point. If I give you, I'd like to be able to ask, is my point equal to some other point? Okay, so I want an equals method. Usually we usually call it equals. Okay, so I want this method. Now, what would equals return?
Boolean.
Boolean, because it's going to be either true or false. So here's something that's going to return true or false. I want to know, okay, now, how do I know if 2 points are equal? Now, the 2 points are this and P. Oh, here's a funny thing. A lot of people like to call this, what are my 2 points?
This and that.
This and that. You'll see a lot of people write it this way, this and that. There's this point and that point. Now, I might do this as that P, but now, what would be the code now down here? I got this and that. Okay, there's a X in this, and there's an X in that. What do I want those to be?
Equal to each other.
Yeah, so I want to ask, are they equal to each other? What else do I need to ask?
The same thing with the Y variables.
So this dot Y equal that dot Y. Now, pardon me?
The little and in between there.
Right, and then I say, I need both those to be true. So I say and. So I need this dot X equal to that dot X and this dot Y equal to that dot Y. What do I do with this answer?
You return it.
Yeah, return it. And that's it. There's the code. Return this X equal to that X and this Y equal to that Y. Okay. And then, some people would rather call this P. So it'd be this X equal to P's X and not thus. There's no thus here. This, thus, and that. Okay. Okay. And, it's a matter of style. Do you prefer it that way? Do you want it be this X equal to P's X, this Y equal to P's Y, or do you like the this and that? It's pretty common to use this and that. Okay. This point and that point. Now notice I could have done the same thing over here. I could have called this that, move this point to that point. Okay. So you can it's actually a matter of style how you want to do these. Okay. Now notice now I have a method that has a return value. It tells me whether 2 points are the same. So for example, if 1 point represents the center of my circle, The other point represents the center of my square, and I'm wondering, is the circle centered at the center of the square or not? Then I might want to ask, is P1 dot equals to P2? So then I might want to go up here and say P3 dot equals to P1. Okay, now that returns a value, so I should save the value. Okay, my answer is P3 dot equals P1. Now I just moved P3 to P1, so this should give me back true. If I moved P3 to be P1, then it should be true now that P1 equals P3. On your hand, before I moved it, that would have been false. After I move P1 to be, after I move P3 to be on top of P1, P3 dot equals P1 should be true. And also, I'll always get the same answer here. If you reverse the roles of P1 and P3, you'll get the same answer. So it doesn't mean it's the same code. Here, this is P3, that is P1. Here, this is P1, and that is P3. But the equals is symmetric. So it doesn't matter if I ask if P3 is equal to P1 or if I ask if P1 is equal to P3. I'll get the same answer if I wrote the code correct. If I goofed up, I may not get the same answer. But as long as I don't goof up, I should get the same answer. Okay? All right. Now part of what we're doing is a game of asking yourself, what are all the things I think a point should be able to do? I'm designing a point. What are all the things I ought to be able to do with a point? And so far we can make them. Okay, so we can make points. We can move them around horizontally and vertically. We can move it to someplace. Okay, we've got a couple ways of moving it. We can say, we can give it the X and the Y coordinate of where to move to, or we could say move to this point. Okay, and then we can ask if 2 points are equal. Okay. Okay. Now, here's something that we can't do quite yet. Let's try, let's see. Suppose I want to print what X is, what P1.x equal P1.x. I want to print out something about the point. I want to print out a little message. Okay. I want to print out what is the X value in P1. Okay. And that'll work the way we've done it. So, okay. So step through. Well, I'll just go to the lab. Go to the end. See, there's P1.x is 5. And if we look at our picture over here, we can follow our P1 link, and it's 5, 4. Okay. So we can print out a little thing about X. Okay. And if I wanted to, I could extend that and say, I could tell you what the Y value is in P1. Okay. So I could, okay. So down here, so I tell you what P1's X is 5 and P1's Y is 4. Okay. I printed out that. Okay. Now, here's an important thing. It's very common in objects to want the data in the object to be what's called private. See, I can put the word, notice I put the word public in front of all these. That means that these things can be called by anyone, okay? But I might want the data to be private. Okay. When I make the data private, see, I get an error message now. I can't ask what is P1.x. By making the data private, I've said that you're not allowed to look inside. your code can't look inside of this method. Now, it's a little bit early for us to explain why that would be, you'd want to do that. But that's one of the important things you could do. You can make the fields private, then no one can see inside of your object. Okay. Now, if you do that, and if you do want them to know what the value of x is, you have to do things like the following. You have to give a method like the following. You have to say public int get x. Oops. I have to write a method that lets somebody retrieve the x out of my point. Okay, so this would just be return this dot x. Okay, and then I can do a public int get y, return this dot y. And now up here, I can, if I want to print my object, I would say p1 dot get x and p1 dot get y. Okay, now I'm back to where I was. I've made the data private, so now I have to use what's called accessor methods. I have to ask the object to tell me what's inside of it. I made the data in the object private, and the thing about making data private is then if the object wants to, it can just simply not let you see what's inside the data. It could, for example, not give you a get x and a get y. It could truly keep the data in there private. Okay, and it's going to, as we do, next week we'll talk a little bit more about why you'd want to do this. But this is one of the mechanisms that Java gives you. You can always make a field in a object private, and then after you've made it private, you can grant access through it using an accessor method like this. Okay, so now I can print now that printing will work. Okay, see, I can print them. Okay, so I had to use the accessor method to be able to get the x out of the point. Okay, now this brings up an important thing. It's nice to be able to print. Here's what I really want to do. I want to print P. I want to just print P1. Okay. So, well, let's see what happens if I print P1. Okay. That's not very useful. Notice that Java did print something. When I got to system.out println P1, it printed something, but it's kind of useless. What this is this is the address in memory of where that point object. See, here's point 1. That it's actually in memory in your computer. And see the @ sign saying it's the point is at that address. But that's not useful to me. I really want to know what's in it. I want to know the x and the y value. To get that to work, I have to write a special method. Okay. So there's a special method you can put in any class. Public string toString. You put what's called the toString method in your class. The toString method is what Java uses when you print your object. See, if you just print your object like that, Java looks to see if you have a toString method. If you don't have a toString method, it prints that address information. But if you have a toString method, it prints whatever is here. So, for example, I can return. Okay, this is kind of stupid. I'm going to return hello. Notice that when I printed P1, Java called my toString method and it printed hello. Okay, and if I print out P2, it's going to print out hello again. Now, what I really want to do is I want to print out what's actually. This is kind of dumb. I'm showing you that the Java. If you define a toString, Java will use it. No, it doesn't matter how dumb it is. So there, Java used my toString. Okay, what I really want to do is print out something that's useful about x1 and I want to somehow return a string. Now I'm returning a string that's this dot x in it, and this dot y in it. So here's what I think would be a good looking string. I want a left, usually when we write points, we write them with parentheses notation. So I'll write this parentheses plus this dot x plus comma space plus this dot y plus close parentheses. That's a little bit tricky to read. Oops. I'm building a string that I want to be printed when somebody calls print my object. And I want to print the point in kind of a nice way. The way you usually print points in algebra class. Left paren, number, comma, number, close paren. So there's the left paren. Then I have to concatenate. This will automatically get converted to a string for me now. Since I've got a string over here on the left, this will now make a string out of that number. Then I'll put the comma and a space. The space is kind of optional. It makes it a little bit easier to read. I mean, if you did it like this, the numbers would just be squished together. There'd be no space, no comma, no space after the comma. Put a space there, makes it read a little better. Then the next number. So now visualize this. I go to the end. Now you can see how my points printed out nicely. Print line. Okay, now here's what I don't want to do. And this is something you'll see a lot of students do, and a lot of textbooks even promote this. I could create a public method called output. Okay. And output, here's what I'll do. I'll write it to look like this. Okay. What does this do? This is saying I want my method to output itself to the console. So I would use it like the following. I would go up here and I might say something like P1.output yourself and P2.output yourself. This is actually considered really bad programming style. Okay. And unfortunately, a lot of textbooks teach this idea, and a lot of students think that this is the right thing to do, that you should have an object that can output itself to the screen. Okay. And what it's doing is that it just literally calls system.out.println. Notice I'm using the same string here that I used in toString, so it's going to print it's going to print the same thing. Okay. And if I visualize this, it's going to work. This line here will work just like this line here. Okay. Now I'll show you in a second like why one's better than the other. Okay. So if I go here, the output's going to look exactly the same. So you might think like, well, what's the big deal? Why not use one or the other? What's the big deal between having an output method and having a print line method? Okay. Now, what's better here is, since this is toStringing this thing automatically, I can do something like the following. I can say P1 equals see, I can put a string in front of, see, now this is going to call toString for me. And then I'm saying I want to put in front of that string, this string that says P1 equals whatever this is. Okay. And then I want to do the same thing with the other one. I want to say something like P2 equals that. Now I can't do that with this one. At least it's really hard to. Like watch how, suppose, okay. Let me move this down here. So here's going to be P1, P2. They're just going to print out. Then I kind of make things a little bit better by putting a P1 in front. Okay. So, oh, what did I forget? Okay. Now look at my output. See, there's the points printed, but here it's a little bit easier. P1 is 54, P2 is 00. Now I want to fix these to look better. And it's going to be a little bit tricky. It's not going to work as well. So this is the last thing I'll do. If I want to make these look better, I have to do something like the following. I have to type it on essentially 2 lines of code. So this will print out the P1 equals. This will print out the rest of the information. And then I have to do that. Now this is really kind of not, this is why an output method is really a bad idea. It doesn't work anywhere as nicely as the toString does. So I have to do something like this. Okay, so notice that to get what would be a nice single line of output requires me to type 2 lines of code to get 1 line of output and 2 lines of code to get the other line of output. Go down here, run it. Notice I got the same output, see, but I had to write kind of messy code. That single line of output took 2 method calls, one to print line to print this part, and then a call to output to create this part. Okay, the output method is very inflexible. It doesn't work very well because it prints directly to the console. It's hard to use it with other things. ToString is incredibly flexible. It's a brilliant idea. It returns a string that you can do whatever you want with. You could print it. You could combine it with some other string and then print it. So the right idea is that an object should turn itself into a string. An object should never print itself. Okay, so this is bad. An object shouldn't print itself. An object should convert itself to a string. Okay, and this is a kind of a general principle is you want objects to do the least amount of work that's useful. So see, this is kind of doing more work than you really want it to do. It's building that string and printing it out. The fact that it's doing 2 things is the bad thing here. It should only do 1 thing. Try to do only 1 thing. See, this is good because it only does 1 thing. It says, here's a string. Then you get to decide what to do with the string, whatever you want. Getting the string is more versatile. You can do whatever you want with the string. Here, that string, you don't get to see it. It just gets printed out, and it's hard to work with it. For example, a simple example is you can't change the indentation even. Okay, like over here, if I wanted to, I could if I wanted to, I could put a bunch of spaces there. No, I could do the same then too. Well, but you by being able to mix this string, like I could put something after this. Okay, yeah, here I can just here I could do the following. Like watch this. I could print both points on 1 line. Okay, I can't do that with this. So that's something I can do with this. I can't do with this because that systemed-out print line printed a whole line. I can't get everything out on 1 line. See, I can get P1 is 5.2, P2 is 0.0. See, I can get all my output in one line because I got back strings, so I can do whatever I want with those strings. Like right here, I can put an extra space there so they weren't run together. Okay, but I can't do that with this. This prints out its own line. This prints out its own line, so it's hard to combine them. I could go back here and change the code so that this thing doesn't use print line, it uses print. But now I have to do more. Then I have to go back up here to get an extra print line after this to get a blank line after that. So if I do, whatever I put here, if I put print or print line, it's bad. Yeah, I'm going to get stuck. No matter what I put there, print or print line, it's bad because it's very hard to mix this with anything else. ToString mixes real well. ToString, see, I can just see P1 plus the string version of this plus P2 plus the string version of this. Okay, so ToString is great, and it shows you a kind of a general idea that there's a sweet spot for each method to do just the right amount. This does too much because it creates a string and it prints it. It's overworking, and by doing too much, it's becoming hard to work with. This is the sweet spot. It creates a string out of your object, then you can do whatever you want with that string. Unfortunately, I know a bunch of textbooks that teach this kind of thing here, that an object should print itself. Very wrong. It's never a good idea to teach an object to print itself. It's always right to teach an object to stringify itself, to make itself into a string. Okay, well, we could quit there. So your homework assignment is going to be very similar to this. Your homework assignment is going to be ask you to add features to a class, just like we've been adding features to this point class as we went along. We just said, let's add a feature that does this. Let's add a feature that does that. Your homework assignment is going to be, I'm going to describe a couple classes for you and ask you to add features to them. Okay, and that'll be your homework assignment. Just adding features like this, and there'll be a program that tests your code. Okay, so look for the assignment up there later today, and then on Monday, look at it over the weekend, and then on Monday we'll go over it real carefully, and you should be able to answer questions by then about it. Okay, and this example will be up on the course website. Okay, so this example will be that you can review this example after class. Okay, so then have a nice weekend. Look for the homework assignment. Oh, when you see the homework assignment, if you have any questions about it, send me emails. Okay, so when you see the homework assignment, read it. And if you have questions about it, send me email, start looking at it. And then on Monday, we'll be able to do more detail about it. Okay, so have a nice weekend and send me emails if you have questions. Bye-bye.